We are going to learn about stoichiometry in this video. Stoichiometry always gets a bad rap because people think the name sounds scary, but really all stoichiometry is you're going to do calculations using the balanced equation. So you're just going to do math using the balanced equations, okay? So think about your balanced equations. They're very similar to a recipe. They tell you the ingredients, they tell you what's going to form, what you're going to make, they tell you the amounts of each of these things. All right. So if you wanted to change that recipe, okay, you could use these amounts and change it in any way you want it. And that's very similar to here to stoichiometry. Okay. So don't be afraid about the word. It just means we're going to do calculations with the balanced equation. I want to start simple here. I just want to show you a basic recipe equation. Okay, so if you notice here, this says it takes 2 eggs, 2 cups of flour, 1 cup of sugar, and 2 cups of milk to make 12 cookies. All right, it's set up like a reaction form. I don't think this would make very good cookies, but it's just a nice little example here. So if you notice, there's a ratio for every ingredient and product. Okay, so if you just pick two of the ingredients, say for example, the eggs here. You need 2 eggs for every 12 cookies. Okay, so if you put that in a ratio, it would be 2 for every 12. It can simplify down, but we're not too concerned about simplifying that down here in chemistry. All right, so we compared a reactant essentially to the products. All right, but we could also do this if we compare reactants to each other. For example, you need 2 cups of flour for every 1 cup of sugar. All right, so it'd be a ratio between the flour and the sugar. And these are not a ratio between like a reactant and a product. It's a ratio between two reactants. All right. You can, do this with another reactant. So you need 2 cups of milk for every 12 cookies. So that's a ratio for a reactant compared to the product. So it's 2 to 12 again. All right. So no matter the ingredient, no matter the product, you can compare a ratio between a reactant and product or compare the reactants to each other here just by looking at the balanced equation. So let's take that idea of a ratio now and apply it to a balanced chemical equations. All right. So instead of using a little recipe, we're going to actually use some chemistry here. So notice, all right, you have your equation up here. All right. So you can make comparisons just like we did before. Based on this balanced equation, you need 2 molecules of hydrogen for every 1 molecule of oxygen. So notice it's 2 here for every 1. All right. So that ratio would be 2 to 1. We're comparing reactants to each other. You can compare the product to one of the reactants. For example, you need 2 water, all right, for every 1 oxygen. So 2 water would form in the balanced equation for every 1 oxygen. So it's 2 to 1, all right. You can compare a reactant to the product. So you need 2 hydrogen molecules for every 2 water, okay? These are obtained just by looking at the balanced equation and making the ratio, all right? Because you're using the coefficients, the moles here, we call this a molar ratio. And that's basically all Stoich is. You're looking at an equation and you're using a ratio here along with some math. As we've already seen, these coefficients in the balanced equation can represent a ratio of moles between reactants or products or between a reactant and a product, okay? They can also represent a ratio of molecules, liters if you're dealing with gases, or atoms, but not grams, okay? You can't look at that previous equation we just did on the previous slide and say there's 2 grams of hydrogen for every 1 gram of oxygen. No, okay? The coefficients do not relate to a ratio of grams. Remember, grams take into account molar mass, all right? So there, you can't just look at the coefficients to get a ratio here for grams, but it works for moles, molecules, liters, or atoms. All right. So literally what we're doing is we're just going to be converting from one substance to another here. All right. Maybe you're starting with an amount of a reactant and you're trying to figure out how much product will form. Or maybe you are starting with a specific amount of a reactant and you want to know how much of another reactant you need. So you're switching substances in a Stoich problem. All right. But you have to use your molar ratio to get there. All right, and I'll show you how to do this. But in order to do any Stoich problem, you must have the equation correctly written and balanced. This is why writing equations correctly, maybe doing symbols, charges, crisscross, predicting the products, and then balancing them are so important because if you don't have the equation correctly written, it can mess up your entire problem here now once we do these Stoic things, okay? So you really need that equation. If it doesn't give you the equation, you need to write it correctly and balance it. Before we jump into a problem here, I just want to show you the format here of these Stoic problems. And, depending on the problem itself, some of these steps might be skipped, or you might start in a different area, but it gives you a basic gist here. So a lot of times you will start the problem with grams of a reactant. It can even be grams of a product. It really doesn't matter here, okay? Your goal with every Stoic problem, this is important to remember. Obviously, after you write your equation, balance your equation, your goal with every Stoic problem is to get 2 moles. Okay, in order to use the molar ratio, you must be in moles. Okay, so you'll just take your grams, convert it to moles. All right, but those are easy conversions. We've done those previously. All right, but once you're in moles of your one substance, this is where you use your molar ratio to convert to moles of another substance. Okay, so this step right here is really the only new step here. And it's not really that difficult, but you have to get the molar ratio from the balanced equation. Okay, essentially you are switching substances here as well. You're going from, say, a reactant to a product, right? And then depending on what the problem asks, all right, you're in moles now, they might want grams, they might want liters. So you just do one more conversion, all right, to get to the units that they want, all right? So the bottom part here shows how this would look in terms of, the dimensional analysis here. So you start with your grams of your one substance. So you immediately write that unit on the bottom. There's always a certain number of grams for 1 mole. You might have to do a molar mass here, all right? And then once you get to moles, because your goal with every Stoic problem is to get to moles, that's when you use this molar ratio. And notice, we actually switch substances here. We have the moles of the reactant on the bottom, the moles of the substance we're starting with on the bottom, and then the moles of the substance we're going to on the top. In this case, we just have it labeled as the product, all right? And in this problem, we wanted to go to grams, so we just kept going. There's 1 mole for a certain number of grams. Again, you might need to do a molar mass here. And I did leave you some notes here. You could easily substitute liters in for grams if you're dealing with gases. You can skip the grams in the beginning altogether and start with moles, all right, and end in moles, all right? So you just have to watch the problems and see what you're being asked here. But this is the basic format for a Stoic problem. So we're ready to do an example here. Let's just jump right in, all right? So this problem says you have sodium and chlorine gas reacting to produce sodium chloride. And we want to know how many moles of sodium chloride can be produced from 3.56 moles of sodium. So the first thing people usually ask is, how do I know this is not just a basic mole conversion problem that we've done previously? Okay, so here's the dead giveaway. Here's how you know this is not just a basic mole conversion problem. Okay, so if you notice, you're given, to start this problem, 3.56 moles of sodium. And the question says, how many moles of sodium chloride can be produced? You're switching substances, okay? They are giving you moles of sodium, but they're asking you about moles of sodium chloride. As soon as you see you switch substances, you know this is Stoic, okay? In all the other mole conversions we've done, you might be starting with moles of sodium, and then you're asked about, say, like grams of sodium or atoms of sodium. So the substance itself didn't switch. All right, once you see that you're switching substances, you know it's Stoic. And the first thing you need to do in any Stoic problem is write the balanced equation. All right, so you have to sift through this. You have to maybe use your types of reactions here to do this. So in this problem, it tells us sodium and chlorine gas are reacting to produce sodium chloride. So it seems like they gave you the entire equation in words. You just have to actually write it out now. So sodium is Na, all right? Chlorine gas, remember, is going to be Cl2 because chlorine is a diatomic, and it's producing sodium chloride. Remember, this is an ionic, so you would have to do symbols, charges, crisscross here. All right, so if you remember, sodium has a 1 plus charge, chlorine has a 1 minus charge. So I wrote the symbols, I wrote the charges, and when I crisscross, it's just NaCl. All right, so the last thing you have to do here is balance it. Some people get so excited that they wrote the equation correctly, they forget to balance it. And if you don't balance these, it will mess up your entire problem. All right, so it looks like I have 2Cl, so I'm going to put a 2 over here. Well, now I have 2Na. So now I have 2Na. All right, so now it's balanced. You need to write and balance your equation once you realize it's a Stoic problem. You must have it and it has to be done correctly. Okay, So now we're actually ready to do the math here. It's going to be very similar to a mole conversion problem, very similar to a dimensional analysis problem. All right, so you start with what you're given. So we were given here 3.56 moles of sodium. Because we're doing stoic, because we're switching substances, it's very important here to actually label the substance now. When we were doing mole conversion problems, I said it wasn't as important, but now it's important. You need to know which substance you're dealing with. The people who label their substances are the people who get these problems right every single time because they're not confused about which substance they're dealing with. Okay, so I'm starting with 3.56 moles of sodium. We said your goal for every stoic problem was to get 2 moles. Well, you're in moles already in this problem, so that makes this a lot easier. Okay, your goal with every stoic problem is to get to moles. We're there. So now you put your multiplication symbol, you put your conversion line. Without even thinking, you know what goes on the bottom. Whatever unit's on top, you write on the bottom. So I got moles of Na on the bottom. Okay, so now what we're trying to do here is, remember, we're trying to switch substances. We're trying to use our molar ratio from the equation to switch substances. I know moles of sodium are on the bottom. I get the number of moles of sodium from the balanced equation. If you look here, right, here's the sodium, and how many are there? There's 2. Okay, so there's 2 moles of sodium on the bottom. All right, and then we're trying to switch to sodium chloride according to the problem. So our moles of sodium chloride go on the top. And from the balanced equation, how many moles of sodium chloride are there? Here's your sodium chloride. There's 2. Okay, so remember, your goal with every stoic problem is to get to moles. Once you're in moles, okay, the moles of what you started with go on the bottom. So in this case, I started with sodium. So the moles of Na go on the bottom, and the moles of the substance you're going to go on the top, right? And you get these numbers right from the balanced equation. So moles of sodium on top and bottom cancel. Your units, your friends are telling you you're in moles of sodium chloride, which is what the problem wants. So you're done. You don't have to go any further here. Okay, so you are done with this problem. All right, when you do your math here, all right, you have to watch your sig figs. All right, you'll notice 2 divided by 2 is just 1. So this is going to come out to be just 3.56 moles of sodium chloride. All right, so the label, the sodium chloride label in the answer is not as important for this because there's only one answer for this problem. It's more important that you use the labels when you're doing the problem so you know which substance you're in. All right, if this problem had more than one answer, you definitely want to include the NaCl part here with your answer. All right, so correct units, correct sig figs are important. Your goal with every stoic problem is to get to moles after you write that balanced equation, and then you go from there. So now we can try another example here. This problem wants to know how many moles of O2 are produced when 3.34 moles of aluminum oxide decompose. So again, I know this is stoic because I'm starting with 3.34 moles of aluminum oxide, and the question is asking me about moles of oxygen. I switched substances, so I immediately know this is stoic, so I immediately know I need to write the balanced equation. So you have to kind of sift through your problem here to figure out what's actually happening. Okay, if you look at this, it's telling you the O2 is produced when aluminum oxide is decomposing. All right, so I'm starting with the aluminum oxide and it's breaking down. All right, so how are you going to get the formula for aluminum oxide? Symbols, charges, crisscross. Okay, remember, aluminum here is going to be 3 plus, oxygen is going to be 2 minus. So I wrote my symbols, I wrote my charges. When I crisscross here, formula of aluminum oxide is going to be Al2O3. All right, and it's telling you it's decomposing. So that means it's breaking down. So this is where this requires you to know, all right, hey, look, a decomposition. What happens in a decomposition reaction? Oh yeah, it rips apart into its elements. So I know that Al is going to form, and it's not diatomic, so it just stays as Al. And O is the other element, but it's diatomic, so it's O2. All right, notice the problem only asked you about the O2, but there is another product here. The Al is still forming. All right, so these are the products that form. Again, don't forget to balance it. When you do your balancing, you should end up with 2 here, 4 here, and 3 in front of the oxygen. All right, so you need the balanced equation first once you realize it's stoic. Okay, Now we're ready to start the problem. Write down what we're given. 3.34 moles of the Al2O3. All right, remember, your labels here are important. We're starting in moles of aluminum oxide. Put your multiplication symbol, put your conversion line. Your goal with every Stoic problem is to get 2 moles. We are in moles, so that's great. It saves us a step here. Without even thinking, my moles of the Al2O3 immediately go on the bottom. Whatever unit's on top, you immediately write on the bottom. All right? How many moles of Al2O3 go on the bottom? You get that number from the balanced equation. There are 2 of them. All right? So the moles of the substance I started with go on the bottom. Once you're in moles, the moles of what you're starting with go on the bottom, and then the moles of the substance you're going to go on the top. Well, the question is asking me about moles of O2. So O2 goes on the top. How many moles of O2 from the balanced equation? Well, there's 3. Okay? Moles on top, bottom, cancel. All right, notice I labeled my substances, so I know that my units here are canceling. I'm paying attention to my friends. All right, so now my units, moles of O2. The question wants to know moles of O2. So again, I'm done. This is kind of a shortened version here of a Stoic problem. All right, but my units are where I want to be, so now I just need to do the math here. Watch my sig figs. So when I plug and chug this, it should come out to be 5.01 moles. All right, 3 sig figs, and you have moles for your unit. So again, write your balanced equation once you realize it's Stoic, and your goal with every Stoic problem is to get to moles. This example is going to be a little bit more fun. So we have 10.1 grams of Fe, and they're telling you it's 3 plus, okay? This 3 plus is here for a reason. That's probably going to help us when we write our balanced equation, or when we do one of the formulas. We need to know the charge there on the iron. That's why it's there. We're adding this to a solution of copper 2 sulfate, and we want to know how much solid copper would form. So I immediately know this is a Stoic problem, because they're giving me grams of iron to start, and they're asking me about how much copper would form. So I'm going from iron to copper. I switch substances, so I immediately know this is a Stoic problem. So the first thing I need in a Stoic problem is the balanced equation. So they're telling me the iron is added to copper 2 sulfate. So iron is just Fe, and I'm adding this to copper 2 sulfate. So when you do your symbols, charges, crisscross, they actually cancel. The Cu is 2 plus, the SO4 is 2 minus, so it's just CuSO4, all right? And they're telling you here, or they're asking you how much solid copper would form. But you need to realize that's not the only product here. You have to be able to analyze this, use your types of reactions to figure out what's going on. So when I look at this, I can see that Fe is an element and the CuSO4 is a compound, so I immediately know this is a single replacement reaction, right? So it doesn't explicitly, say what type of reaction this is, but if you don't know that and you don't predict the products correctly here, you won't balance the equation right, and you'll probably get the problem wrong. So being able to do formulas and writing equations is huge, as I've been saying, okay? So in this problem, the lone element is going to try to jump in and kick out the Cu. All right, and obviously this question is saying this happens, so you don't need to use the activity series here. You could check to see, can the metal here, the iron, kick out the copper. He is higher on the list, so he can do it. So copper gets kicked out. He's not diatomic, so he's just Cu. That's one of your products. But then the iron's going to jump in his spot and join with the SO4. This is where that 3 plus is important. In order to write the formula, I need to do symbols, charges, crisscross. Well, the Fe is 3 plus according to the problem. The SO4 is 2 minus. So when I crisscross, it's going to be Fe2 SO4 3. That's why that 3 plus was given here in the problem, because if you didn't know that, you couldn't write the formula correctly. All right. So I predicted the products that would form. Now I just need to balance this correctly. Okay. So remember, it needs to be balanced. So when I do this correctly, you should have a 2 in front of the Fe, a 3 in front of the CuSO4, and a 3 in front of the Cu. All right, so now you have your balanced equation. Now you're ready to do the problem. All right, so you start with what you're given, 10.1 grams, and it's Fe. Remember, your labels here are important. Knowing which substance you're in is very important so you can see when you switch substances in the problem. All right. So your goal with every Stoic problem is to get to moles. In the previous examples, we started in moles, but in this problem, we're not in moles. So your goal with every Stoic problem is to get to moles. I have no choice but to get to moles. So without even thinking, whatever unit's on top, you immediately write on the bottom. So you have your grams of Fe on the bottom. All right. Your goal is to get to moles. Well, we know a conversion from grams to moles. We know, all right, there's 56 grams of Fe from the periodic table for every 1 mole of Fe. All right, this is where people get in trouble. All right, they would go to the balanced equation and say, well, there's 2 moles of Fe, right? No, remember, our conversions involving grams were always 1 mole for a certain number of grams. So anytime you have grams to moles here in these problems, it always has to be 1 mole for a certain number of grams. You don't look at the balanced equation yet. That's something very important to pay attention to. It's always 1 mole for a certain number of grams. If this was a compound, if Fe was a compound, you might have to do a molar mass here as well. All right, so just get used to doing maybe a couple molar masses in these problems. So we have grams of Fe on the top and the bottom, so they cancel. Well, now you're in moles of Fe. Well, your goal with every Stoic problem is to get to moles. You're in moles. Now you can use that molar ratio. Multiplication symbol, conversion line. Whatever's on top immediately goes on the bottom. So moles of Fe go on the bottom. All right? How many moles of Fe? Once you're in moles, you write your moles of the substance you're starting with on the bottom, you get that number of moles from the balanced equation. So now you look at the equation and see that there's 2 moles of Fe. All right? And then moles of the substance you're going to on the top. Remember, it's a molar ratio. You have to have moles on the top and the bottom. Moles of the substance you started with on the bottom, moles of the substance you're going to on the top. And according to the question, they're asking about how much solid copper. So we're going to the copper, which is on the product side here. So there's 3 moles of Cu. Okay, we're getting that number right from in front of the Cu. So the moles of Fe on the top and the bottom cancel. You're in moles of Cu. In the previous examples, we stopped there because the question was asking us how many moles. This problem says how much solid copper would form. Whenever they say how much, that's grams. So you're in moles of Cu right now. You're not done. So you just keep going. Multiplication symbol, conversion line. All right. So now whatever unit's on top goes on the bottom. You have moles of Cu. All right. How many moles of Cu? Remember, for every 1 mole of Cu, there's a certain number of grams of Cu. You don't look at the balanced equation for this step. If you have moles and grams, it's always 1 mole for a certain number of grams. All right. Again, you just get this number right from the periodic table. There's 64 grams of copper for every 1 mole of copper. All right. So your moles of Cu cancel. Now you're in grams of copper. Again, if that was a compound, you might have to do a molar mass there, but we lucked out. It was just an element. We could look it up. All right, so now we're ready to do this. Remember, do your math correctly. You're multiplying across the top, getting a number, multiply across the bottom, get a number, then you divide the 2 numbers. All right, if you're really good with parentheses, you can kind of do that in one swoop. You still need to watch your sig figs. We started with 10.1, which is 3 sig figs, so our answer needs 3 sig figs. When you plug and chug this correctly, you should come out with 17.3 grams. Okay, 3 sig figs and grams are your units here. Watch your sig figs, watch your units. All right, just again, I want to point this out. The only place in the problem where you could ever have more than 1 mole is right here at the mole ratio step. All right, if you have grams involved, it's only ever 1 mole for a certain number of grams. Okay, only at the mole ratio step could you ever have more than 1 mole. Okay, so just be careful with that. So here's another example of a Stoic problem, but we didn't start and end in moles. Here's your chance to try one of these on your own. So in this problem, it tells you silicon computer chips are made using this reaction. Sometimes you're given the reaction here. Sometimes if you might not be able to predict the products correctly or something like that, you're just given the equation. So you just use it. All right. But this problem wants to know how many grams of Mg are needed to make 9.3 grams of silicon. All right. So you can pause the video, try this. And when you rejoin the video, you'll see the complete solution here so you can see how you did. Hopefully when you did it, this is the answer that you got here. All right, so you had to start with your grams of silicon. All right, your goal with every Stoic problem is to get to moles. So there's 1 mole for 28 grams of silicon. Get this number right from the periodic table. All right, once you're in moles of silicon, the moles of the silicon go on the bottom. That's what you started with. Moles of what substance you're going to go on the top. They're asking about the mg. Remember, we're getting those numbers right from the balanced equation. This is the only step in the problem where you could ever have more than 1 mole. Now that you're in moles of magnesium, we know there's 1 mole of magnesium for every 24 grams of magnesium. When you plug chug, use your sig figs, your answer should come out to be 16 grams. We have another example we can try here. This problem says you have potassium metal reacting with water to produce potassium hydroxide and hydrogen gas. So it looks like they gave you the entire reaction in words, all right, but they didn't give it to you, so you're gonna have to write it. But you have 12.1 grams of potassium reacting completely. They want to know how many liters of H2 gas can be produced at STP. So I immediately know this is a Stoic problem because they gave me grams of potassium to start, and they're asking me about liters of H2. So potassium becoming H2. You switch substances, so it's going to be a Stoic problem. I need the balanced equation here. So potassium metal is going to be just K reacting with water. That's H2O. All right, and it's telling you it's producing potassium hydroxide. So that's an ionic compound. You have to do symbols, charges, crisscross. All right, remember K would be K plus. Hydroxide is OH minus. When you crisscross, it's just KOH. All right, plus hydrogen gas, that's H2. All right, so you wrote the equation, but don't forget to balance it here. You need to balance it. So you have a 2 in front of this, 2 in front of this, and a 2 in front of the KOH. So now you have your balanced equation. You're ready to do your Stoic problem. You start with what you're given, 12.1 grams of potassium. Remember, include your labels here. Your goal with every Stoic problem is to get to moles. Multiplication symbol, conversion line, whatever unit's on top, you immediately write on the bottom. All right, your goal is to get to moles. So I know there's 1 mole of potassium for every certain number of grams of potassium. All right, when I look this up on the periodic table, there's 39 grams of potassium for every 1 mole. Remember, you're not allowed to look at your balanced equation when you have your grams. It's just 1 mole for a certain number of grams, always. Grams on top, grams on bottom, they cancel. Now you're in moles, all right? So your moles of K go on the bottom, moles of the substance you started with on the bottom. Get that number of moles from your balanced equation. So according to the equation, there's 2 moles of K, moles of the substance you're going to on the top. They're asking me about the H2, so I have to go to the H2. When I look at the balanced equation, there's no number in front of that, so it's just 1. All right, moles of K on the top and the bottom, so they cancel. Now you're in moles of H2. Again, follow your units. Your units are your friends here. So according to my friends, I'm in moles of H2. I want to know how many liters of H2. So I need to keep going. Multiplication symbol, conversion line. Whatever unit's on the top, you immediately write it on the bottom. So moles of H2 go on the bottom. But this time we're not going to grams. They're asking me about liters. So we know for every 1 mole, there's 22.4 liters here. All right. So because we're at STP, because we're doing gases, you can use that equation, that conversion that we learned. We know that there's 1 mole for every 22.4 liters. Just like grams here, you can only have 1 mole for a certain number of grams. You can only ever have 1 mole for 22.4 liters because that's the conversion. You don't look at the balanced equation here. Moles of H2 on the top and the bottom, they cancel. You're in liters of H2, which is what the problem wants. When you plug, chug, sig fig, again, you have 3 sig figs. It's going to have to be 3.47 liters. All right, don't forget your unit and watch your sig figs. We have a few more examples here that we can try. You're more than welcome to pause the video, try these, and then see how you did, but I'll walk you through this one. So this is telling us we're combusting 4.20 moles of C2H2, and we want to know how many moles of O2 are required to do this. Okay, so sometimes people get scared here because they think, oh my goodness, they're asking me about both of the reactants. Doesn't matter, okay? Follow your steps to do Stoic. You're switching substances, so it's going to be Stoic. Just follow your steps here. But it does tell you need to balance this equation. So when you balance this equation correctly here, it's one of the combustion types. You would do the carbons first, then the hydrogens, and then the oxygens. But when you do the oxygens, you quickly realize you have to double everything. So once you balance it, I'm just going to show you the balanced equation. You get a 2 in front of this, 5 in front of the O2, 4 in front of the CO2, and a 2 in front of the H2O. All right, so remember, in order to do Stoic, you do need the balanced equation, whether they tell you or not. Okay, you need that equation. So I start with what I'm given, 4.20 moles of C2H2. My goal with every Stoic problem is to get to moles. I'm there. Multiplication symbol, conversion line. Whatever unit's on top immediately goes on the bottom. So moles of C2H2, moles of what I'm starting with on the bottom. I get that number from the balanced equation. There's 2 moles, okay? Moles of the substance I'm going to on the top. The problem is asking me about moles of O2. So O2 is the substance I'm going to on the top. Get that number from the balanced equation, okay? There's 5. Remember, this is your molar ratio step here. Moles of C2H2 cancel. You're in moles of O2, which is what you want. All right, so now you're ready to plug, chug, sig fig. We started with 3 sig figs, so we must end with 3 sig figs. It come out to be 10.5 moles. Watch your units, watch your sig figs. Another fun example here to try. We got sodium and chlorine gas reacting to give sodium chloride. It's telling us if you end up with 1.98 grams of sodium chloride, how many grams of Na did you start with? Again, don't be scared because they're giving you an amount of the product. They're telling you end up with a certain amount of NaCl. How much of something did you start with? It doesn't matter. It's still Stoic. You switched substances. You need to do Stoic. You need to write the balanced equation here. So we have sodium, which is Na, chlorine gas, which is going to be Cl2 because it's diatomic, giving sodium chloride. Remember, NaCl, symbols, charges, crisscross. When you balance this, you have 2 Na and 2 of the NaCl. All right, start with what you're given, 1.98 grams here of the NaCl. All right, your goal with every Stoic problem is to get to moles. Remember, I know this is Stoic because I am starting in grams of NaCl and they're asking me about grams of Na. All right, so that's how I know this is Stoic here. I switched substances. So your goal with every Stoic problem is to get to moles. So I know grams of NaCl have to go on the bottom here. I know that for every 1 mole of NaCl, there's always a certain number of grams. Remember, anytime you have grams, it's 1 mole for a certain number of grams here. So this is NaCl. The only way you can get the number of grams is by doing the molar mass. So you got to get used to this. You might have to do a few molar masses in your problem while you're doing it. So I know that there's 1 Na times 23 is 23. And then there's 1 Cl times 35 is 35. And when you total this up, you have 58 grams per mole. All right, so there's 58 grams of NaCl for every 1 mole of NaCl. Your grams on the top and the bottom cancel. Your goal with every Stoic problem is to get to moles. You're in moles. Now you can use your mole ratio. Okay, obviously your moles of NaCl must go on the bottom. Whatever unit's on top goes on the bottom. How many moles of NaCl now? You get that number from the balanced equation. There's 2. And then the moles of the substance you're going to on the top. They're asking me about the sodium. So moles of sodium on the top. How many moles of sodium according to the balanced equation? There's 2. Only in the molar ratio step can you ever have more than 1 mole here. And you get those numbers from the balanced equation. Moles of NaCl on the top and the bottom, they cancel. I'm in moles of sodium now according to my units. Again, include your labels here. I know right now I'm in moles of sodium without a doubt because I included the labels here. There's no confusion, all right? But I want to know grams of sodium, so you got to keep going. I know that for every 1 mole of sodium, there's going to be a certain number of grams of sodium. It's just Na, so you can look this up on the periodic table. There's 23 grams of sodium for every 1 mole of sodium. So my units are where I want to be. I just need to plug, chug, sig fig. Okay, so when you do this, when you do your multiplying across the top, get a number, multiply all the numbers across the bottom, get a number, and then divide those 2 numbers, you want 3 sig figs here. So you should end up getting 0.785 grams. All right, that's correct units and correct sig figs. One final example here to try. I'm going to tell you to pause the video, try it, and then when you rejoin, you'll see the entire problem done for you already. So pause the video right now and try it. So hopefully this is the answer you got, 6.02 grams. Remember, you have to write the equation first, balance it. Once you realize it's stoic, we're switching substances here, okay? So you got to write and balance the equation. Your goal with every stoic problem is to get 2 moles, and then once you're in moles, you use your molar ratio, and you get these numbers right from the balanced equation. Moles of the substance you started with on the bottom, moles of the substance you're going to on the top, all right? Anytime you have liters involved, there's always 1 mole for 22.4 liters. And anytime you have grams involved, there's always 1 mole for the number of grams. Okay, I needed the molar mass here of the MgCl2, so I had to show the actual work for that. All right, so write and balance the equation correctly first for every stoic problem.